Hello, folks. Welcome to part 15 of Learning Rust from Scratch. And in this video, we're going to continue with chapter 3, that is the third chapter, and specifically the functions section. And then we have comments and control flow that we'll do in separate other videos. So, functions, right? So, it's prevalent in Rust code. That's what they say. I think it's prevalent in almost any code wherever you need to do something repeatedly or whenever you need to separate out some logic, some lines of code into something specific, to be able to segregate them and say call them as a unit. Right? So we've already seen one of the most important functions in the language, the main function. So that's the entry point of many programs. So we've also seen the FN, which is a keyword for function, which allows you to declare new functions. Rust code uses snake case as the conventional style for function and variable names, similar to I think Python. So in which all letters are lowercase and underscores separate words. Here's a program that contains an example function definition. So here's this. It calls another function and it prints another function, right? So hello world and another function. So we define a function in Rust by entering fn followed by a function name and a set of parentheses which takes a set of arguments. So the curly brackets tells the compiler where the function body begins and ends. We can call any function we've defined by entering its name followed by a set of parentheses. Because another function is defined in the program, it can be called from inside the main function. So notice that we defined another function after the main function in the source code. We could have defined it before as well. Rust doesn't care where you define your functions. You can actually define it before or after, I think. So only that they're defined somewhere in a scope that can be seen by the follower, right? So I actually didn't try out the variables section before. Let me actually try out all of these. I think variables I tried, yes. Shadowing and all we tried. I think we tried this also. We tried all this stuff. And let's just see. And leave this, close this up. Maybe I can try this data type stuff in as you can see over here, like run it in the playground or whatever it is, right? So here there's no output, but basically you can see how it's 32-bit unsigned and all that. And I've seen these bool character tuples. I'm not sure. Can we actually open this in a playground for a particular board? Okay. Um, yeah, I can just do play.rustlang.com or .org, I think. So 155, and then you can actually mention. Let me just do functions for now. I'll actually copy this. Okay, I have run this, so it's fine. I can actually copy now and put this in play.rustlang.com. Okay, it doesn't come up. Rustlang.org. Okay, so now we put this. We say, what do you want to do? Run, and it runs. So hello world as a function. And what is this? Oh, this is to give input, right? So as debug, release, and then stable, Nike, I think, and then builds and beta seminar. Edition 2024, backtrace on of aliasing model tree code that is accepted by tree borrows may be declared undefined behavior if it's interesting. Aliasing model is I don't know what this is. MIRI. If it's changed, I think they show a blue over here. Here also, if it's changed, I think they show a blue. Interesting. So configuration, different editors. You have simple, is Monaco, classic stuff. And then have the key binding for ACE editor, VS Code, and all. You can use Monaco, maybe VS Dark Plus, or just VS Code, the blue one, or this one. Or you can just use simple and just go with it. ACE editor, GitHub Dark, there are so many of them. Cobalt, something that I saw here. This is the ACE editor, I think, by AWS. I'm not sure if it's the AWS or who. It's the ACE editor, right? So ACE.c9, it's the Cloud9. I think it's by AWS now. I think it's Cloud9. Yeah, Cloud9 is actually a AWS thing now. Cloud ID. So it's Cloud ID for writing, running, and debugging code. And cool. So yeah. So maintained by the primary editor for Cloud9 ID and is the successor of the Mozilla Skywriter Best project. And it's a great editor. I've used it before. So now, so I'm actually putting the function even before calling. So it runs, and can I actually cut the function and put it later? So it, actually here they put it later. So it's fine, after the main function is put, so not before. Usually it's expected that it's before and all that. So let's start a new binary process. So it says we could have defined it as before as well. Doesn't care where you define your functions, only that they're defined somewhere in a scope that can be seen by the caller. So let's start a new binary project named functions to explore functions further. Place the another function example in source main and run it, and you should see the following output. The lines execute in the order in which they appear in the main function. So main function is the main thing. So first the hello world message prints, and then another function is called and its message is printed. So parameters or the arguments, you can define functions to have parameters, which are special variables that are part of a function's signature or the input. So when a function has parameters, you can provide it with concrete values for those parameters. Technically, the concrete values are called arguments, but in casual conversation, people tend to use the word parameters, words parameters, and argument interchangeably for either the variables in a function's definition or the concrete values. So the concrete values are apparently called the arguments, um, and so parameters are the inputs. These parameters again change, vary, they are variable and they can change and all that. You can give different values. So arguments are what you use the concrete values to call. So for either the variables in a function definition or the concrete values passed in when you call a function. So in this version of another function, we add a parameter. So x integer 32-bit, the value of x is this, and you get 5. So the value of x is 5. So here, does it copy or what happens here? The declaration of another function has one parameter named x. The type of x is specified as integer 32-bit. When we pass 5 in to another function, the print line macro puts 5 where the pair of curly brackets containing x was in the format string. So let's say x integer 32-bit. The value of x is, and then say x, and then say 10. Says hello world, the value of x is 10. Can I do x equal to x plus 5? Okay. So we expect this. Compile, couldn't compile playground, will playground due to one player. Okay. Cannot assign to immutable arguments. It's an immutable argument, not a mutable argument. So um, Can you say mu? It says 15. What is the value of x here? Value of x, let x equal to 10. X in main is, let's see what it does. Does it compile? It compiles. In main, the value is 10 only. So in this, it's 15 because we change it, right? So is this a copy? Maybe. Um, can I say mute? Missing keyword. Okay, let. This is another X basically. Variable does not need to be mutable because okay, does not need to be mutable is a warning. Does not need to be mutable. Uh, okay, but it still works. So it says it got shadowed. So yeah, there are three. There are two of them. It says 11:21 and then 12:9. Basically, this doesn't have to be mutable, or this one doesn't have to be mutable, and the other one also. But anyways, so yeah. So now to mutate this, you need to just say mutate. So it's actually copying by value, and then we are saying it can be mutable, so it's allowing a mutation. So here you can actually see the declaration of another function as one parameter named x. The type of x is specified as integer 32-bit. When you pass high into another function, the println macro puts high where the pair of curly brackets containing x was in the format string. In function signatures, you must declare the type of each parameter. This is a deliberate decision in Rust's design requiring type annotations in function definitions, meaning the compiler almost never needs you to use them elsewhere in the code to figure out what type you mean. Uh, so you have to mention the type of each parameter. Why? Because it means the compiler almost never needs you to use them elsewhere in the code to figure out what type you mean. So you don't have to put some stuff in the code inside the function or outside in the calling function in the caller about what type it should be to figure out what type you mean. The compiler is also able to give more helpful error messages if it knows what types the function expects, because there's an expectation and then there's a reality, right? So in defining multiple parameters, separate the parameter declarations with commas like this. So you have different parameters. This is integer, this is character, so there's a label, so 5 hours and whatever here. So this example creates a function named print label measurement with two parameters. The first parameter is named value and is an integer that will get. Second is named unit label and is type character. The function then prints text containing both the value and the unit label. Let's try running this code. Replace the program currently in your functions project with the preceding example. So we can just copy this and put this in and should be able to see if I has 5 hours. Cool. So because we call the function with fire as a value for the value and h as a value for a unit label, the program output contains those values. Statements and expressions. So function bodies are made up of a series of statements, optionally ending in an expression. So far the functions we've covered haven't included an ending expression, but we have seen an expression as part of a statement because Rust is an expression-based language. So this is an important distinction to understand. Other languages don't have the same distinctions. So let's look at what statements and expressions are and how their differences affect the bodies of functions. So expression is something that has a value and it is not being assigned to anything, I think. So, or it could be assigned. Statement has a left hand side and then a right hand side of it. So let's see. So statements are instructions that perform some action. and do not return a value. Yeah. So there's no returning of the value. The statement does not have a value, but expressions have a value. Yes, that makes sense. So evaluate a resultant value. Let's look at some examples. We've actually already used statements and expressions. Creating a variable and assigning a value to it with the let keyword is a statement. In listing 3 1 let y is equal to 6 is a statement. So if they're containing one statement, so function definitions all are also statements. The entire preceding example is a statement itself in itself. As we will see below, calling a function is not a statement. So calling a function is actually an expression, and if it's assigned to something together, then it becomes a statement thing. Statements do not return values, therefore you can't assign a let statement to another variable. So statements do not return values. So let y equal to 6, you can't assign it, right? Oops. Basically, this does not compile again. So if you can't assign a let statement to another variable, so as the following code tries to do, you'll get an error. So expected expression found let statement only supported directly in conditions of if and while expressions. So unnecessary parentheses around assigned value, remove these parentheses. Unused parentheses on by default, generated one warning, could not compile. So let y equal to 6 is a statement, does not return a value, so there isn't anything for x to bind to. This is different from what happens in other languages such as C and Ruby, where the assignment returns the value of the where the assignment returns the value of the assignment. Oh yeah, I think you can do x equal to y equal to 6. So assignment returns the value of the assignment. In those languages you can write and have both x and y have the value 6. This is not that is not the case in Rust. Okay. So let's see. So print line and to say x and now y. Let's say let x equal to let y equal to 6. Let's just not do this. Can I run this? I do not command. So it should give an error. So only supported directly in conditions of if and while expressions. Okay. Unexpected token. So we need to actually add a semicolon between this. Okay. You might be missing a string literal to format it with. So interesting. So you always need a string literal. I do know that. So unnecessary parentheses around assigned value. Here it says want for unused parentheses, or else you can actually say allow. So one warning and one error, I think. Here we can just say allow, and then no warnings. If I say allow, should give an error. Yeah, a built-in attribute with a similar name exists. Allow. Cannot find an attribute allow. Okay. Cool. So it's an attribute. It's called. I don't know what that means. We need to learn that. Can I do why? Can I do this? Not found in this scope. Interesting. How about let y? So cannot be formatted as the default formatter. Interesting. Cannot be formatted as the default formatter. For more information about this error, E026 doesn't implement. Okay, what happened? Okay, cannot be formatted as the default formatter. Standard FMP display. Hmm. I wonder what's going on here. Note in format strings you may be able to use for pretty print, colon, question mark. Maybe it's for the X. I think it's the problem. So colon question mark. This error originates in the macro create format arguments NL, which comes from the expansion of the macro println and nightly builds commit McKinsey macro backtrace for more info. So standard format display is not implemented for it. So X is a tuple, is it now? Okay, it compiles. Interesting. So X, the value of X is basically an empty tuple for some reason. So this does compile. It's a weird thing. And if I say X equal to Y equal to 6, does this work? Yep. So it becomes tuple. And basically this is an expression and this has no value. Can I say equal to Z equal to 10 and have let Z? I think that is not possible. You cannot assign to this expression. So this is an expression and you're trying to assign to that expression. That doesn't work. Doesn't implement thing. So pick and property print. You still can't assign this and 6 equal to 10 doesn't make sense. You can't do that also. So Z is just unused type annotation is needed. Oh, let's just say it's a integer type of width. Unused variable value 6. And if I actually do hash, it's still the same. Great. So let's actually look at this. So y equal to 6, x equal to y equal to 6 is a very weird thing. So expressions evaluate to a value and make up most of the rest of the code that you'll write in Rust. So it makes up most of the rest of the code. So expressions are everything is what they're trying to say. I think. Consider a math operation such as 5 plus 6, which is an expression that evaluates to the value 11. Expressions can be part of statements. So in listing the 6 in the statement is an expression that evaluates to the value 6. Calling a function is an expression. Calling a macro is an expression. Oh wow. A new scope block created with curly brackets is an expression. For example, y equal to let x equal to 3, so that will be x equal to 3, and then x plus 1 is 4, so y equal to 4, I think. This expression is a block that, in this case, evaluates to 4. That value gets bound to y as part of the let statement. Note that x plus 1 line doesn't have a semicolon at the end, which is unlike most of the lines you have seen so far. Expressions do not include ending semicolons. If you add a semicolon to the end of an expression, you turn it into a statement. Okay. And it will then not return a value. Keep this in mind as you explore function return values and expressions next. So if I say if I actually say equals and then say x plus 1, so should it be actually, I think x is only in this scope, so here it should just give error. X is defined in this scope and dies in this scope, so it says found println so unexpected token, let's stack input now. And you cannot find value x in the scope. The binding x is available in a different scope in the same function. Could not compare it. So it's saying this is the place where x is available. So let's just get rid of x and take up this, run this, and you should be able to see 6. And if you make it a statement, I think this should become a tuple or a unit. Yeah. So you should be careful, I think, to provide a statement. This is a statement and it doesn't return a value. Statement doesn't have a value. Expression has a value and it returns the value. Expression is the last line and What if you have a statement and then an expression 6, 5 plus 5, 10, 10 is there, so it says unused arithmetic operation that must be used. Arithmetic operation produces a value. Yes, but it's not used. Let to ignore the resulting value. And can I actually put two statements here? It should basically say unused values. It should say the same thing in this case also, I think. Yeah. Unused values. And if I actually put a expression in between all these, then is it a problem? Expected count x, yeah. Expression should come last, I think. So yeah. So okay, x plus 1 and x plus 5 are not necessary. And this is 15. Cool. So function with return values. So functions can return values to the code that calls them. The caller gets the value, right? So we don't name return values, but we must declare their type. After an arrow in Rust, the return value of the function is synonymous with the value of the final expression in the block of or the body of a function. You can return early from a function by using the return keyword and specifying a value, but most functions return the last expression implicitly. So if you want to return in between, you just say a return in between. Here's an example. So implicitly, this is return the last expression. Here's an example of a function that returns a value. So this is 5. So you just say 5 and the value is 5. So just take it out and that is 5. There are no function calls, macros, or even let statements in the 5 function. So no functions, no macro calls, nothing. No let also, just 5. Just the number 5 by itself, that's perfectly valid function. Just note that function's return type is specified to as integer third of it. Try running this code, the output should look like this. So let's just copy this and put this here. Let me remove this and let me see what it says. So try adding a return type, expected unit or basically an empty tuple, but found integer. So it's called a unit, I think, empty tuple. Oops. And empty tuple doesn't implement this, so we'll have to probably do colon, yeah, colon question mark or something like that. I think it's like this. So if this is intentional, replace it with an underscore. I think colon question mark and then this X over here should help. Try adding missing mismatched values. Okay. Expected thing found integers. So if you just remove this, I think you should get, yeah, there was no expression. So by default, I think all functions return nothing, which is an empty tuple. They return something, which basically the empty tuple, which contains nothing. So it's the unit. So I think every function returns something. So every function call is an expression, and if the expression has no value basically means empty tuple, and hence unit basically the empty tuple. So there are no function calls. Blah, 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 return value. The phi in phi is the function's return value, which is why the return type is integer third of it. Let's examine this in more detail. There are two important bits. First, the line x equal to 5 shows that we are using the return value of a function call to initialize a variable. Because the function 5 returns a 5, that line is the same as the following x equal to 5. Second, the 5 function has no parameters and defines the type of the return value, but the body of the function is a lonely 5 with no semicolon because it's an expression. If there's a semicolon, we'll get empty. We'll get empty if there's a semicolon. We'll get empty tuple or unit basically. and if there's no semicolon, it basically returns file, and you actually have to have the accordingly matching file, integer 32-bit or 64-bit, whatever it is. Let's say you say 64-bit, and accordingly, or you need actually your arrow. Um, and yeah, so it's all it's a lonely file with no semicolon because it's an expression whose value we want to return. Let's look at another example. Plus one, so x plus one and then 6. So you can just run this and you can find the value is 6. It's returned back and it's 6. Running this code will print the value of x is 6, but if we place a semicolon at the end of the line containing x plus 1, we'll get mismatched types, I think. Changing it from an expression to a statement, we'll get an error. So compiling this code produces this mismatch type. The main error message mismatch type reveals the core issue with this code. The definition of the function plus one says that it will return an integer 32-bit, but statements don't evaluate to a value which is expressed by empty tuple, the unit type. Therefore, nothing is returned, which contradicts the function definition and results in an error. In this output, Rust provides a message to possibly help rectify this issue. Um, it suggests removing the semicolon. Uh, I'll remove the semicolon to return this value, which will fix the error, right? So if you actually just do this semicolon, so you can actually see remove this semicolon to return as well. Cool. So that's all I had for this video. I'll see you next one. Bye.